Let me start sharing my screen also. So do let me know if my screen is visible to you. Is my screen visible to everyone? Okay, so yeah. So today we are going to start real sorting algorithms. Okay. So again we are going to start with the problems, right? So problem is quite simple. Problem says that let's say you are having two arrays and in today's class I won't be giving you links of the problem, but yeah, I would be telling you problem. Simple. Let's say you are having a two arrays, A1 and A2 of both size n, so both has a size n. Take a, let's say 1 6 2 9. Let's say here 3 2 5 1. Okay, now you can rearrange this array. You can rearrange both the arrays according to yourself, but what you have to maximize, let me tell you, you have to maximize summation of after rearranging. So suppose you rearrange to something like this, you rearrange it to 1 2 9 6, and you rearrange to uh, 3 1 5 2. Let's say you rearrange to this. So after rearranging, you have to maximize a1i into a2i, summation of a1i into a2i. Like if I rearrange a1 to this and a to this, my summation would be 1 into 3 plus 2 into 1 plus 9 into 5 plus 6 into 2. So this would be summation for this case. But you need to maximize this value. So you have to rearrange in such a way that this value is maximized. And you need to tell the maximum value. What is the maximum value of summation of a1i into a2i? So you guys take your time. So everyone is able to understand, right? Everyone understood the problem statement, right? Hmm. Everyone who is not able to understand, you can ask again. Is everyone clear with the problem statement? That re Okay. See, you are having two arrays A1 and A2 of both size n. Now, both are having integer values only. You have to rearrange. You have to rearrange both the arrays according to yourself. You have to rearrange in such a way that summation of I is equal to 0 to n minus 1. Summation of a1i into a2i is maximum. Like suppose I rearrange a1 into this. Rearrange means swapping elements, right? Swapping elements and putting it anywhere. Similarly, if I am rearranging this into this, now I have rearranged. So summation will be 1 into 3 plus 2 in 1 into 3 plus 2 into 1 plus 9 into 5 plus 6 into 2. This is a summation. But suppose if I rearrange somewhat like this, 2196. So I would be having some summation as 2 into 3 plus 1 into 1 plus 9 into 5 plus 6 into 2, right? Both the summations are different. So I need to rearrange in such a way that this summation is maximum. And you have to return the okay. And you have to return the maximum summation. Mhm. Mhm. Okay. Okay. Now let okay. So I guess everyone is clear with the problem statement, right? Should I move to solution cap? Okay. So there's a proper if like there would be one intuition in your mind. Okay, like I'm having this array. Above array is 16295. Below array is 1325. Uh, 1 second. Let me write it as 3152. This is the below array. So so if I rearrange in such a way that maximum element of above array and maximum element of below array is at same index. Suppose maximum element is here is 9 and maximum element here is 5. So they are at same position. Now go to second maximum. Second maximum is 6. Second maximum is 3. Third maximum is 2. Third maximum is 2. And first. Now This summation is going to be maximum. It means that I'm taking maximum element from A1 and taking maximum element from A2, putting it at same index. Then second maximum of A1 and second maximum of A2, putting it at same index. Similarly, third maximum, fourth maximum, so on. Now the summation which you will be getting now, the summation you will be getting now is 9 into 5 plus 6 into 3 plus 2 into 2 plus 1 into 1. So this summation is maximum. This, I guess, this intuition was in everyone's mind, right? Okay, this will eventually get maximum value. Okay, can you prove me why it is correct? Can you prove me why it is correct? This is a core logic. Whenever you see a problem, this is a core logic. How you can do. But now, hmm hmm okay. But there are, suppose there are B1, B2, G1, G2. Suppose you are multiplying these two. Suppose you are multiplying this one and this one, and you are multiplying this one and this one, right? You are saying that this will get a maximum value, right? But there could be a chances कि B1 into G2 plus B2 into G1. You are having a summation in between, right? You are saying that multiplying two big values will give you eventually a bigger number. But what I'm saying, ki, ha, I got a point, but there's a summation in between. So if I multiply a smaller number with another big number, that will also give me a bigger number. It means the summation can give me a bigger number. Yes or no? It is possible, right? Because we are having a summation of all the pairs. Uh-huh. Mm-hmm. 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 Three. No, no. 9 and 6 both are of one array. So 9 into 3 and 5 into 6. Mm-hmm. Mm-hmm. Okay. Ha. Ha. But okay. Now you can see it, but okay. Now let me. Visually you can see it, but how to prove in the interviews, right? Because in interviews they won't be having a proof from your example, right? So let me give you a proof for this. Sometimes you can prove it by intuition, but sometimes they need a mathematical proof. Suppose A1i and AJ, B1i and BJ. Suppose you are having an array of A and you are having an array of B. So A1i and AJ. Suppose these two are the largest and these two are the smallest. Let's forget about smallest and largest. Let's forget about smallest and largest. Let's say multiplying this one and this one is giving you a larger value. So A1 BJ plus AJ BI is giving you a larger value than this one. A1I, B1I, and AJ BJ. Suppose this is giving a larger value. Suppose. Now, okay, let's put everything on the left side, or let's put everything on the right side. That would be no. Okay, let's put everything on the left side. Anything would work. I'm putting everything on the left side, so it is A1I BJ plus AJ B1I plus AI BI, sorry, minus AI BI minus AJ BJ. Till this one everyone is clear, right? That is greater than equals to 0. Okay. Now, now what we can do? Let's common A1 AI from here. Let's take AI common. It will be BJ minus BI, and let's take AJ common here. So plus AJ BI minus BJ greater than equals to 0. Till this point everyone is clear? Yes or no? Till this point everyone is clear, right? Now let me take this as a common. So I am putting minus here. When I put minus here, it will be BJ minus BI. That's correct now. Taking bj minus bi common, bj minus bi, ai minus aj greater than equals to 0. Now let's swap it. Okay. Mm, okay. For this product, can you prove from here? Okay, how we can say? Can you prove from here? From this product, you can easily see that for this product to be greater than equals to 0, or to be follow this condition, this has to be positive, and this has to be positive. This has to be positive, and this has to be positive. Both has to be positive, or both has to be negative. So let's consider case both has to be positive. If you want to if you want to have a product as a positive, so both has to be positive. So bj minus bi greater than equals to 0, and ai minus aj greater than equals to 0. So from here you can see bj is greater than equals to bi, and from here you can see ai is greater than equals to aj. You paired ai with bj, and you paired bi with aj. So you are it means that bj is greater than equals to bi. So bj is a larger number. Similarly, ai is greater than equals to aj. So aj is a larger number. So you are putting larger number with a larger number, and smaller number with a smaller number. From here you can see that putting larger number with a larger number is giving you a bigger value. From see, we took this condition, and with the help of mathematical means we are reversing the proof. Basically, we are doing in a reverse. We are taking that, suppose this sum is bigger, then we are proving that taking bigger number and multiplying them is giving a bigger value. This is what the proof is actually. Similarly you have to do proofs in some greedy algorithms. You have to prove it. So I hope everyone is able to understand the proof of it. So it's very handy, and you guys have to remember it. Okay. So this was one of the tricky problem, and this was one of the proof which I wanted you guys to know. So everyone is clear with the problem statement, and everyone is clear with the solution. Solution is quite simple. You have to take larger number with a larger number. So there can be multiple solution. One solution is you sort the array. So on sorting the array, it will be 1, 2, 6, 9. Similarly, below array will be 1, 2, 3, 5. And you multiply the corresponding elements and take their sum. That the sum is maximum. That sum is maximum. So this is another solution, and the proof behind it, why it is maximum, I have told you the proof. Many of you were saying ki we will sort and reverse. There's no need of reversing also. Maximum element is with the maximum element, second maximum is with the second maximum, third maximum with the third maximum, so on. So sort it and multiply the corresponding indexes and take your sum. So that sum will be maximum. I hope everyone is clear till here. Okay, now let's move to another problem. And this problem was asked in one of the OS, Microsoft OS, in my college when MS came. Problem is very simple. Problem says that you are having multiple numbers. Let's say I'm having number 10, 3, 2, 4, 5, let's say 16. You need to sort, this is an array, you are given an array of integers. You need to sort this array according to their number of set bits. Like if I write 1, 1, 10 is 1, this is 5, this is 10, it's 5, right? Hi, sorry. It's 1 0, it's 1 double 0, it's 1 0 1, it's 1 double 0 double 0. You need to sort it according to their number of set bits. The one has highest number of set bits will come first. Like these two are having higher number of set bits. And if suppose they both are having same number of set bits, bigger number will come first. So first we will see which one has higher number of set bits. So here higher number of set bits is this one, this one, this one, two. So the number which is, if number of set bits is same, like in 10, 3, 5, number of set bits is same. So the number which is larger will come first. So 10 will come first, then 5 will come first, then 3 will come first. Now the number which having smaller number set bit. So here these numbers are having only one set bit. So the number which will be bigger will come first. So this is sorted. So you have to sort an array in such a way that the number which has highest number of set bits will come first. If there are many numbers which are having same number of set bits like 3, 10, 5, so the number which is bigger will come first. So in this case 3, 10, 5, 10 is bigger, so 10 will come first, 10 will come first, then 5 will come first, then 3 will come, then remaining these numbers are having only one set bit. So this will come in this order. Let's take another example to understand. Let's say I'm having an array 0, 6, 10, 4, uh, 13, 5. Okay, you guys sort it. This is array. You have to sort it according to above problem. So if I write it in bitwise form, this is bitwise form of these numbers, 13, right? So one, we are left with 6. Huh. Can you tell me which number will come first? The number which has highest number of set bits. So which one has highest number of set bit? 13 has highest number of set bit. So 13 will come first. Next, which will come? Next, we are having two set bits. So two set bits in 6, 10, 5. So these numbers are having two set bits. So if they are having same number of set bits, the number which is larger will come first. So 10 is larger, then 6, then 5. Now the number which has less number of set bits. So 4, then 0. So this is the sorted of A according to our requirement. Here A is in descending order, but it is possible that it is not descending like in above case. So I hope everyone is able to understand the problem statement, right? So you guys try. Okay, I'm sharing the problem link in the chat. Sort the integers in ascending order by number of ones in the binary percentage in case of two or more integers. Okay, okay. It's a similar problem, same problem only, but they're telling you in ascending order means the number which has smaller number of set bits will come first. So same problem. Okay. So someone was saying me a solution sum. Okay, who was saying? Just yes, sir. Okay. So suppose I got number of set bits. Fine. I got number of set bits. Now, okay. Suppose for each number you are having set bits. After that, but how you are sorting? So you have calculated the frequency of each, but how you will sort now? No, no. I got your point. So now you have number of set bits, right? So now I'm asking, ki how would you sort the array according to number of set bits? Number of set bit, right? Key would be number of set bit. So you are having two things, that is set bit, comma, number itself. So basically you are storing it in the map as a pair, right? Map or set. And you are saying that this will, okay, but yeah, but you don't have to use any map or set. Okay. Okay, okay, 1 second. Mhm. One second. You wrote a function to calculate number of set bits. Okay. And you wrote a function to sort. Okay. Means sort according to what? Hmm. So how would you sort? How would you sort? That's the only question. How would you sort? Let's say I'm having number as 10 and I'm having number as, let's say, 13. Let's say I'm having another number as uh, 32. Okay. So let's say this is your array. Okay. Now how would you sort? You know the number of set bit here. Number of set bit is 2. Number of set bit is 3. Number of set bit is 1. Okay. Ha. 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 Okay. Okay. See. See. I will calculate the number of set bit. Set bit calculation is done. Whether it is using AND operation, it is done. Now, after you got number of set bit for each number, what you will do? That is what I want to know. Mhm. Okay, first. Okay. So first you will go to 3. Suppose you went to 3. Then which one will you take? Means suppose you are having a new array that will store sorted numbers. Simple. Now you will iterate on this. You will take 3. You will check the highest number of set bit which is on S. That is 3 is the highest number set bit. So you will go to all the numbers, right? Then you will go to, okay. Mm, but is it okay? One more thing. Let's say 3 is here. Okay, 13 is here. And let's say you are having another number that is 3 now. So it is 7. Let's say you are having 7 here. So let's have 7 here and 13 here. So both are having 3 set bits. So which one you place? So I have told you you will place the highest number here. So how would you know this is highest or this is highest? And suppose you are having multiple numbers with 3 set bits. So you don't know, right, which number is highest. You also need to know which number is highest. Okay. So I hope everyone is clear with the problem statement. I hope, and I hope anyone having any ideas which handles both number of set bits and actual value of a number, that is highest and lowest. Anyone knows which takes both these cases? No one can. Okay. Anyone got any solution idea in their mind? Whether it is right or wrong, we'll figure out later on. But anyone else except just and her? Yes, Harsh. Okay. I got a problem. Uh, there are multiple ways. One is hash map, right? What you can do, you can maintain a map of int comma array int or vector int. So let me tell you the solution which everyone was having in mind, but they were not trying to implement. So you are having a map, hash map. Those who don't know hash map, no need to worry. We are going to cover it in our next few classes. But for now, those who know, you are having a map, hash map, with key as an integer. And integer, this integer is actually set number of set bits, and this is a vector or you can say array. So you are having for each set bit you are having value as array of numbers. So you would calculate for each number, you would calculate number of set bit and you would put that number. Suppose number of set bit is 3, so mp3 dot pushback that number, let's say 7, mp3 dot pushback, let's say 13, so on. And after that, after doing this for all the numbers, you are having hash map 3, that is 13 comma 7, let's say, or let's say 7 comma 13, anything. Let's say 2, you're having let's say 6, let's say 12, let's say 24, or let's say 24, 12, 24 in between, let's say 24 in between, 24 and 12, in order to solve it in a beautiful way. And similarly for all the numbers, let's say for 1 you are having 4, 8 and 2 in this way. So you get a hash map where key is your number of set bit and value is actually a vector of those numbers. Now what you would do, you would go to all the keys, that is you will add it to all the keys and you will individually sort it according to ascending or descending. So if I have to sort in descending order, so it will be 13 comma 7 because now there is no relationship of number of subbits. Similarly here 24, 12, 6. Similarly here 8, 4, 2. Now you will again iterate from, you will make a new array and you will iterate from the very beginning. You will put all the numbers in this order. That's it. This is your answer. This was one of the way, but you are using space and you are using multiple things, and interval will get angry and he will say you to leave. So yeah, those who are not knowing hashmap, do not worry about that. We are going to learn a new technique that is called as comparator function. And for this only, I told you to, it's a must join class. Comparator function. There are many times when normal sorting, like in Java we do a dot sort. In C++ we do sort a dot begin comma a dot end, or if it is an array, we do sort a comma a plus n. We do in C++ in this way. There is a third parameter that is with this sort function. Like in functions, we are having some default parameters, right? I guess you know default parameters. I guess you all know. In Java also, you have a third parameter, a dot sort, and this parameter actually take a callback function. Similarly, in C++ also, you are having third parameter that is sort a dot begin comma a dot end comma comparator function. This is a callback function. Similarly, here also comparator function. If you are not giving it, it is by default taking it as a null, and there is no need. It will sort automatically in ascending order. Default callback function is sort in ascending order. As simple as that. Do not worry. We are going to learn in detail. So there is a third parameter which we generally don't pass while solving our problems because we sort in ascending order. But there is a third parameter in sorting, and here also you are having third parameter. So we are going to talk about that only. So what this third parameter tells us? This third parameter is actually a function, comparator function, which is by default sort in ascending order, or you can create your own comparator function, which will sort according to your requirement. Okay. Now let me ask you a question. Suppose I'm making a function, bool comparator, CMP, int a and int b. Okay. This a and this b, this is the order in which you are passing. It means that a is written first and b is written second. Let's say a is written first and b is written second. Means suppose you are having an array where a is written before b. Like a was here, b was here. So a was written here and b was written here. Let's say their value is 3 and 7. I want to return false. I want to return false if a is okay. I have to sort it in ascending order. I have to sort this array in ascending order. So for ascending order, a should be smaller than b, right? Like here 3 and 7. So a is smaller than 7. So it is an ascending order. But suppose a was 7 and b was 3. Now is it in ascending order? Kya? No, right? So whenever you get a case ki hey, this element is not in ascending order. When it will be not in ascending order? When a will be greater than b. When a is greater than b, it is not in ascending order. So you would return false. Okay, now this is not correct. Return false, it means that you need do not worry. Return false, it means that you need to swap. Means this ordering is wrong. This ordering is false, you need to swap. Otherwise, if a is smaller than b, means this ordering is correct. Return true. So means this ordering is correct. Similarly, In sorting functions, you also make a comparator function of your own, which take two elements. Like here we are having integers, so two integers, and these two integers are passed integer a and integer b. Suppose I'm writing, so it means that integer a is before than integer b. Now, when you don't when you don't want to swap, then in that case you have to return true, and when you want to swap the ordering, you need to return false. How actually sorting is implemented uh, internally? It generally goes with every possible pairs and think about it ki whether I have to swap or not. Checks whether these two positions are relatively correct or not. Like suppose A was 3 and B was 7. So these two are relatively correct. So there is no need to swap. But suppose if A was 7 and B was 3, it means that these are not relatively correct. It means that it is not relatively correct. So return false. So it is not correct. Return false. So swap this. So whenever your condition fails, whenever your ordering fails, you return false. It means that this will swap. So B will come here, A will come here. In case of 7 and 3. Okay, I'm going to explain with the help of code also. Do not worry about that. So this is how comparator function is written. Let me code it because it is not that much theoretical. But I will give you one trick to remember in the end. And we are going to solve some problems here for this topic. Let's okay. Let's have an array first. Int ARR of size 6, 1, 5, 3, 2, 9, 4. I want to sort it in ascending order. So sort a comma a plus 6. If I do it, if I print it, it will be sorted in ascending order. Okay, it should be ARR. Let me run it. It will be in ascending order now. Ascending order. But I want to write my own comparator. Okay, now let me sort it in descending. Let me sort it in descending order. So descending order would be sort it in ascending order, then reverse it. But now I want to write a comparator function which will be sorting it in descending order. Bool comparator. So comparator function takes two parameters which are actually keys of your array. So these keys are integers. So it will have two parameter int a comma int b. I want to sort in descending order. Descending order means that b should be a should be greater than b, right? मतलब बड़ा नंबर पहले आना चाहिए, right? This is what is the meaning of descending order. बड़ा नंबर पहले आना चाहिए. It means that if a is greater than b, it is correct. If a is less than b, it is not correct. Did you got my point? Example 7, 3. Descending order में sort करना है. So bigger number will come first. Like if big, and this is the order. Right? This order में तुम्हें लिख रहे हो, right? In comparator function, the order in which you are passing integer is actually order in which your array is. Relative order same है. जैसे कि a would be here and b would be here. It is a relative order. So अगर descending order में मुझे sort करना है, so bigger number should come first, then smaller number. So suppose a was 7 and b was 3. So a पहले लिखा गया, right? Bigger number is written first and smaller number is written true in the last. Similarly here, if this is the case, if suppose a is 3 and b is 7, but a is written first, it is not correct. So जिस केस में तुम्हें swap करना, the case in which we want to swap, you have to return false. So किस केस में swap करना? In this case we have to swap. So if a is less than b, return false. Otherwise, return true. As simple as that. Now I made my comparator function. I would pass it here as a callback function. I would pass this function name. No need to worry about callback, the words and callback function and all. Now let me run it. If I run it, what happened? See, it is sorted in descending order now. Always remember, In comparator function, this is the order in which, like if I wrote a and b, it means that a is relatively at smaller index than b. मतलब a पहले लिखा गया है, फिर b लिखा गया है. This is how internally this is how internally it is implemented. Now, किस केस में स्वैप करना था? When b was larger. Suppose this case, a is 3 and b is 7. If array has to be in descending order, बड़ा नंबर पहले आना चाहिए था, right? So b should come first, but here a is coming first. So if a is less than b, return false. That's why. Means you have to swap. जिस केस में तुम्हें swap करना है, in that case you have to return false. Otherwise you have to return true. So I hope everyone is clear with this thing. Is everyone clear with this thing? Anyone having any doubts? Sorry. Anyone having any doubts? I guess you would be having it. It is the first time you are learning about comparator function. Okay. Now let me solve it for you guys for this problem. Now, okay. Suppose अपने पास now the problem was कि हमें जिसके पास सबसे ज़्यादा बिट है वो पहले होना चाहिए. And in case if both the numbers are having same bit, in case if both the numbers are having same bit, जो नंबर बड़ा है वो पहले आना चाहिए. Let's say a is this, b is this. Let's say a is 5, b is 10. Now these two numbers are having same number of set bits, that is 2 and 2. तो कौन पहले आना चाहिए? In this case should we swap क्या? In this case should we swap क्या? Yes or no? No, we are solving it for descending order only. बड़ा नंबर है जो पहले आना चाहिए, as simple as that. Okay, let's take another case. Let's say a is 16. Okay, my bad. A, b. Let's say a is 16, b is 3. What should we do? Should we swap? Yes or no? In a, number of set bit is 1. In b, number of set bit is 2. प्रॉब्लम क्या था? जिसके पास सबसे ज्यादा सेट बिट है वो पहले आएगा. So इसमें पहले कौन है? पहले ए है. आना किसको चाहिए था? बी को आना चाहिए था, राइट? बिकॉज बी हैज मोर नंबर सेट बिट. सो शुड वी स्वैप क्या? Yes, we should swap. So return false. Okay. Let's take one more case. Let's take A, let's take B. Let's say A is 5 and let's say B is 32. Should we swap? Yes or no? Everyone, should we swap क्या? Number of set bits in A is 2, number of set bits in B is 1. Should we swap? How many of you got the point of swapping and not swapping? Tell me this first. Everyone is clear with this, right? Swapping and not swapping. Yes, guys. Everyone is clear, right? Anyone having any doubts in this? Ashish, Divya, Tanisha, Brinda, what about you? Clear, right? Great. Ashish, you also clear? Okay. Now the first thing is we need to calculate number of set bits, right? So you can calculate number of set bits according to you. Whatever you write and function something else. But I would use internal tools, internal calculation. So int set bit in A is equal to built-in pop count A. This is an internal function in C++, which tells the number of set bits in A. As simple as that. Int set B is equal to built-in pop count B. This will tell the number of set bits in B. Now let me first we will write case of false, means in which we have to swap, as simple as that. So if number of set bits in B is greater than number of set bits in A, should we swap? Yes or no? भाई बताओ, if number of set bits in B is greater than number of set bits in A, should we swap? So what is the value? Return true or false? If set B is equal to, suppose both are having same number of set bits. So if B is greater than A, then return false. बड़ा नंबर पहले आएगा अगर नंबर ऑफ सेट बिट सेम है तो, अदरवाइज रिटर्न ट्रू. एज सिंपल एज दैट. समझ में आया? पहले फॉल्स का केस लिखो. ऑलवेज राइट द फॉल्स केस फर्स्ट. लेट मी एक्सप्लेन यू हाउ. इन योर एरे ए इज रिटर्न एट स्मॉलर इंडेक्स देन बी, बिकॉज ऐसे पास किया गया. ऑलवेज रिमेंबर दिस. जिस ऑर्डर में पास किया गया उसी ऑर्डर में एक्चुअली रिलेटिवली ऑर्डर वही है. इफ बी इज हैविंग नंबर ऑफ सेट बिट्स मोर देन नंबर ऑफ सेट बिट्स इन ए, देन वी नीड टू स्वैप. तो उसके लिए फॉल्स. सपोज बोथ आर हैविंग सेम नंबर ऑफ सेट बिट्स एंड बी इज ग्रेटर देन ए, तभी भी स्वैप करना है क्योंकि बड़ा नंबर पहले आना चाहिए. सो return false. In all the cases, return true. So always remember when you are writing a comparator function, you always have to write the case of false first. This will make your life easier. As simple as that. Let's take an example. Let's check whether we are correct or not. Let's take a case of this uh, 310 to 4 5 16. 310 to 4 6 15. सेम थिंग है क्या? नहीं, 4 5 16. 4 5 16. 4 5 16. Let's sort it according to a comparator function. Let's see. See, जिसके पास ज़्यादा सेट बिट्स था वो पहले आ गया. लाइक these numbers were having two set bits count as 2, and the number which is larger is written first. Like 10 is written first, then 5, then 3. इनके पास number of set bits 1 1 था, so these are written at later on. So 1 1 1, and the number which is larger is written first. As simple as that. Now I hope everyone is clear with this comparator function thing. Now how would you write in Java? In Java also you would make comparator function of a similar type. सेम तरीके से तुम कंप्यूटर फंक्शन लगाओगे इन जावा. नाउ आफ्टर दैट यू वुड राइट एज सिंपल एज दैट. व्हेन यू डू ना ए डॉट सॉर्ट, जब तुम लोग करते हो लिस्ट में ए डॉट सॉर्ट ऐसे, सो यू कैन डू ए डॉट सॉर्ट एंड यू कैन कॉल यू कंपैरेटर फंक्शन. एज सिंपल एज दैट. दिस and you will declare same comparator function like here we declared it. Similarly, you will declare your comparator function in the same way, and you would call just name. So it is actually callback function. So I hope everyone is clear with this comparator function thing. Everyone is clear, right? Anyone having any doubts? भाई बताओ, बता दो मुझे. डाउट्स है किसी के पास तो कुछ भी अभी भी. A minus B, A plus B, I mean, can you tell me? Mm-hmm. Mm-hmm. We will come to that problem. I know what you are talking about. We will come to that problem. Okay. So you are saying that you would have seen that return A minus B greater than return, right? Something like this. No. See, this is the way of writing, how they write and how right. Some would have written A greater than B. Just it. That's it. This is a compare. This is comparator operator, right? Compare operator. What is it? Uh, Yeah, I forgot the name. Logical operator. It says the a comparator operator. Somewhat right. This operator is written true or false. As simple as that. A greater than B, it is returning true and false only. This value is going to be written true or false only. So I don't use operators because I'm not good into that. I've never used. So that's why I manually calculate and manually check and then return true and false. Many of you would have seen the code of this in comparator function return A greater than B for ascending and descending order, because this is eventually returning true or false only. But I'm not good in these operators, right? I've not do this thoroughly. That's why I don't play with these, right? I'm a check. Eventually it is same only, returning true and false only. Okay, I hope everyone is clear with this problem statement. Should we move forward, kya? Or anyone having any doubts? What about others? Everyone understood, right? Okay. So I've shared a link in the chat. It's a replica of the same problem. It's the same replica, right? Everything same. But now it is in ascending order. So I hope you guys can do it. I'm not going to implement it. I will share the code with you in the chat on WhatsApp. But I'm not going to solve it in the class, right? You have to do it on your own. But still you're not able to do it, then we can do it tomorrow. Now, there's an interesting problem. Now let me ask you one thing. Now this problem is asked in one of the interviews. The problem is very clear. Let's say you are having an array. Given an array of string of numbers, arrange it to get maximum number. Can I find it? Kya? Mm-hmm. Here it goes. I'm sending one problem in the chat. Now again, this is very a good problem for the interviews. Read the problem statement, and we will solve it after this. It's 53. We will solve it at 55 or 56. Sorry. Everyone understood the problem statement? Kya? Everyone is able to understand the problem statement? Kya? Anyone having any doubts in this problem? But any logic? Okay, think for one more minute. See, these problems are the problem which you cannot do if you don't know comparator function. As simple as that. According to what? That only you know what you want, what you would do. Irrelevant of means we are not independent of Single or double digit. Hmm. Anyone having any solution in their mind? Mm-hmm. Mm-hmm. Exactly. 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 That is actually the correct answer. Okay. See. Okay. The problem here it is little bit tricky, and for first time, those who are solving for first time, even when I was trying it for first time, I've solved it on Netcode. I've not solved it on Netcode. Okay, I've solved in some into a bit platform. Those who are having less time, right, and those who are preparing for companies, and those who are having 2 or 3 months, right, I would suggest you to do interview bit, only interview bit. So let me tell you the platform. This is the interview bit platform because I've only done interview bit through my college. I've not done DSA to be honest. In my college, I've done CP only. But when it was time for a DSA, I've done interview bit. That's it. So you go to interview bit, go to this programming section, only do only do these problems. That's it. It has only limited number of problems. For arrays, you are having 44. For maths, you are having 29. Binaries are 16. So these are having limited problems, and all the problems are to the topic, and all the problems are independent or they're not being repeated with a different story or different name. So all the problems are totally different, and these are very good problems, really, really very good problems. And Interbit does not accept any unoptimal solution, so it will accept only optimal solution. Suppose the requirement is of big of n, and if you are giving it to big of n log n, it won't accept. It will give you TLE. So they are having very good what you say online judge or tracking system. Okay, let's move to this problem again. Problem says that you are given an integer array and you need to sort it in such a way that after that you need to rearrange this array in such a way that the number which you will form is the largest. So eventually it is rearranging the array or sorting the array such that after we go on appending the numbers, the number which we form is largest. Like if I append this and if I rearrange it to this, I'm getting number as 210. If I append this to this, I'm getting number as 102. Obviously 210 is bigger than 102. So yeah, this is my answer. Same goes with this. So now the problem is how do we rearrange? Do we have to rearrange according to value? Do we have to rearrange according to what factor do we have to take? So that is the problem right here. Someone would say take the smaller number first and then take the larger number, right? This is the solution someone would say. But that is also not correct approach. You take smaller number then take larger number. That will also eventually fail. Let me think of a case. hmm Mm, how do I take smaller number first? Like let's take for single digit. We cannot take smaller number first. If I take smaller number, then yeah. If I take smaller number first and then larger number, it is eventually wrong. If I take larger number, then here we are getting correct answer. And if we take larger number, then here it will fail. So eventually, there is no such small thing, right? Take smaller, a simple thing like take smaller or take larger. But there's one thing which you can do is you can decide which pair will come first. First of all, let me tell you the solution directly itself. I'll prove it later on. Let's say you're having, first of all, convert them into strings. As simple as that. And when you convert them into strings, they are now not numbers. They are strings and they would be compared according to lexicographical ordering. And we have discussed lexicographical order in previous class only. So let's say we are having a number, string as 10, and you're having a string as 100. Okay, A and B. So which one is better to join? If I join A and B, if I do A plus B, it will form this number. If I join B plus A, it will form this number. Which one is bigger? Above one is bigger or below one is bigger? Okay. So means this is a correct order, right? Because we are going to append in this way only, right? We are going to take the first number which is first, when then we are going to append the numbers so on. So this is correct order, right? If we are appending. But suppose if A was 100 and B is 10. Now if we append, we are going to have this number. Suppose A was written first and B was written second. So if we append, we are going to have this number which is smaller. But if we swap it, if my 10 is here and 100 is here, then appending will create a bigger number. So now you got a case ki how would you append? Now you got a comparison. How would you compare? So like A is written and B is written. So if appending A with appending B with A, that is A plus B, this number is greater than B plus A. It means that A should come first, then B should come. Means it is a correct case. Like here, like here. Suppose A is 10 and B is 100. So pending B with A, that is A plus B, is 101. That is greater than swapping. So it means that this is correct order. So if B plus A is greater than A plus B, then we need to swap. As simple as that. So only this thing you have to worry about. Okay, when you have to swap. So let me write directly. So actually I would be having bool comparator. You can name it anything. I'm naming it comparator. It is taking two strings, string A and string B. Always pass it by reference because otherwise you will get TLE. So if A plus B is, or if B plus A is greater than A plus B, it means that if you write B then A and appending this is greater than the previous formation, then you have to swap. Return false. So always think a case of swapping. In that case, return false, otherwise return true. Simple. Now I would create a vector of strings error of size nums dot size. Now I would go to all the numbers and I would convert them into string. Uh, Array of I is equal to two string. Uh, there's a two string function in C++. I don't know the syntax. Two underscore string. Okay. Two underscore string. Then nums of I. So I have converted each number into string. Now I would sort it according to this. Sort error dot begin, comma error dot end, comma comparator. Now I would have a string answer as 0 empty, and I will go to this array and I would start appending. So error answer plus is equal to error of I, and I would return the answer. So the main problem was कि how do we sort it? This was the main problem. Hmm. अरे यार what? Now let me summarize it. What happened? Okay, in case of 0, 0, we need to return just 0. This is the edge case that we did not got. So you can handle it here only. Bool is 0 is equal to false. I will go to Keshav. Keshav, I would go to all the characters of the string and I would check if all the characters are 0 or not. If if answer of I equals to not equals to 0 is 0, let me write it as a true. A0 is equal to false, and if A0 is true means all the characters are 0. Return just 0. That's it. So this is the edge case that we did not see and we were not told also. Uh, what happened here? Heap buffer overflow. So am I comparing it? Okay. Am I taking am I going out of bound cap? Is it? Answer is equal to answer plus area of I. Okay, bool is 0 is equal to true. Where I'm going out of bound here? I'm not going out of bound, right? No. Can I figure out how I'm getting out of bound? Why my heap is overflowing? Oh, my bad. Line 7 character 3. If B plus A, mhm, let me print out if it prints cap. Use test case. Okay, does it print it cap? Okay, okay, my bad. Submit it. Okay, accepted. Okay, one more thing, here. I don't know the proof. Means I know the proof. I don't know actual proof. But whenever both the numbers are same, right? Whenever both the things are same, which are comparison, in that case, always return false. So suppose B plus A and A plus B both are same. In equality case, also have to return false, right? It means the ordering actually doesn't matter. If any case occurs in which A and B both are same, and their ordering does not matter. If you write B first, A first, or B second, A second, it does not matter. In that case, also you have to return false. Otherwise, you will get a runtime error. And to get the proof, to get if you want to read the proof, I don't know the proof, but yeah, comparator function return false code forces. There's a good blog for this. You can go through this, and there's a real proof. Uh, if you want to go through the real proof, this is the real proof why you should return false. And I don't know the reason. I have not studied it in detail, but you should always remember when you should return false if both the arguments are equal. This you should remember. Otherwise, you will get a runtime error. We just saw, right? Now I hope everyone is able to understand the logic. Everyone is able to understand comparator function, right? Anyone having any doubts here in comparator function? Don't go through the proof here. It is not required. Okay, if you are thinking to read the proof, it's totally irrelevant. Now let me ask you a question as a home. Let me give you a question as a home assignment. Uh, I should have opened the problem in the chat. One second. Code forces. This problem is as a home assignment. You have to do it. It's a very simple problem, right? It's a very simple problem of code forces. You can do it as a home assignment. So that's all about today's class. If you guys are having any doubts for this class, you can ask me now. That's it. And we will be tomorrow with new topic that is called as two pointer. Tomorrow we are going to start two pointer and all. Okay. Let me stop recording.